Today, we are diving into a cosmic detective story. We're going to uncover an invisible force field in space that's both a destroyer and a creator. It's a boundary that decides whether a moon lives or dies, and in the process, it actually creates some of the most stunning sights in our entire solar system.
All right, let's jump right into our first mystery, the absolutely gorgeous, but, surprisingly young, rings of Saturn. For the longest time, their origin was a total puzzle. But now we see the rings themselves as the key piece of evidence in a massive cosmic crime scene.
So the big question has always been this: are these rings just ancient leftovers from when Saturn was born, or are they something newer, the result of some dramatic, violent event? Well, all the latest evidence is pointing squarely at the second option.
The leading theory is this incredible idea called the chrysalis hypothesis. It paints a picture of another large moon that used to orbit Saturn, doing its thing peacefully for billions of years. But then, about 160 million years ago, its orbit went completely haywire. It got way too close to Saturn and was just utterly shredded. Almost all of it, 99%, was swallowed by the planet. But that last little 1% of icy debris, that became the glittering rings we see today.
So what kind of cosmic force can just tear an entire moon to pieces? Well, it's time to reveal our main suspect, the murder weapon in our cosmic crime scene. It's an invisible boundary in space called the Roche Limit. The Roche Limit is basically the point of no return. If you're a moon, held together by your own gravity, and you cross this invisible line, the planet's gravitational pull becomes so much stronger on the side of you that's closer to it than the side that's farther away, that it literally tears you apart.
Think of it like a giant game of cosmic tug-of-war. The moon's own gravity is desperately trying to hold itself together, right? But the planet's tidal forces are pulling it apart. And once that moon gets too close, the planet's pull just becomes overwhelming. It's a tug-of-war the moon can't win. But here's where it gets really interesting. The exact location of this tearing point depends on what the moon is made of. If it's a solid, rigid body, a single chunk of rock, it can get a lot closer before it breaks. But if the moon is more of a loosely held together rubble pile, which a lot of them are, it starts to stretch and deform way earlier. For those kinds of moons, the Roche limit is much, much farther out, making them way easier to destroy.
Okay, so we've identified our weapon. Now, let's go look for more evidence around the solar system. Because the Roche limit isn't just some ancient history, it's actively shaping the future of several moons right now. Let's investigate some of these moons already on death row.
This table really lays it all out. You can see a moon like Saturn's Mimas is safely outside its limit, no problem. But then, look at Mars's moon Phobos. It is getting dangerously close to its point of destruction. And you'll also notice Neptune's moon Triton is on that list too. We'll get to that one in a minute.
So how is this happening? It's this really fascinating bit of physics. Phobos actually zips around Mars faster than the planet itself rotates. This creates a gravitational bulge on Mars that lags just behind the moon, and it acts like a constant brake. This little gravitational handbrake slowly saps Phobos' orbital energy, causing it to spiral inward toward its doom at about 2 centimeters every single year.
And get this, we can already see the damage. Phobos isn't a solid rock. It's one of those rubble piles we talked about. And you see those long grooves all over its surface? Scientists now believe those aren't from impacts. They're literally stretch marks from Mars's tidal forces slowly pulling the moon apart. The process of destruction has already started.
So here's the bottom line. Phobos' destruction isn't a maybe, it's a future certainty. In about 20 to 40 million years, it's going to cross that Roche limit, get torn to shreds, and give Mars its very own ring system.
Now let's jump over to Triton, Neptune's largest moon. It's also doomed, but for a totally different reason. It orbits Neptune backwards, against the planet's rotation. This retrograde orbit creates a constant drag that is also pulling it inward toward that deadly Roche limit. It's amazing, right? Two completely different orbital setups, both leading to the exact same destructive fate.
But you know what? We don't have to wait millions of years to see this happen. In 1994, humanity got a front row seat to see the Roche limit in action when a comet got a little too close to Jupiter. So back in 1992, Comet Shoemaker-Levy 9 flew inside Jupiter's Roche limit, and the result was immediate and catastrophic. The comet was ripped apart into this beautiful string of pearls of over 20 different pieces. Then 2 years later, we all watched as those fragments, one by one, slammed into Jupiter's atmosphere. And the power involved was it's mind-boggling. The largest single piece hit Jupiter with a force of 6 million megatons of TNT. It was the first time in human history we had ever directly witnessed the death of a celestial body and its impact on a planet.
After seeing all this cosmic destruction, you have to be wondering, what about our own moon? Is it safe? Well, let's bring this story home. And the good news is, for now, we're totally fine. In fact, our moon is slowly drifting away from us. But the key words there are for now, because in the very, very distant future, the whole script gets flipped. In about 5 billion years, our sun is going to start to die, swelling up into a red giant. Its expanded atmosphere will create a drag that's going to reverse the moon's escape. It will start to spiral back towards us on a final one-way trip toward Earth's Roche Limit.
And this illustrates the final poetic act. As our moon is torn apart, a dying Earth, in its final moments, will be decorated with a magnificent ring system made from the remains of its lifelong companion.
So after all this, what's the takeaway? Is the Roche Limit just some senseless force of cosmic destruction? Or is it something more? Well, I think the verdict is pretty clear. The Roche Limit is both. It is a destroyer of worlds, absolutely. But in that destruction, it becomes a creator of immense beauty. It's the cosmic sculptor that transforms ordinary moons into the breathtaking rings that circle our giant planets. It all comes down to this single, powerful idea. Every ring is the ghost of a former moon. When you look at Saturn, you're not just seeing ice and rock. You're seeing the beautiful ghost of a world that was lost to time and gravity.
And that leaves us with one last provocative thought. The next time you look up at the night sky, just remember it's not a static, unchanging place. It's a dynamic system, always in motion. And it forces us to ask, which of the moons we see today are here to stay, and which are just rings, waiting for their moment to be born?